This video covers review problems for section 2.4. Solve the right triangle shown in the figure, round lengths to 2 decimal places, and express angles to the nearest tenth of a degree. We need a calculator to perform these. So if A is 22.3, and C is 10, then from this angle I see that I'm given the hypotenuse. And I want to solve for all the other lengths. I want to solve for A, and I want to solve for B. And then I want to solve for big B. All right, so we have B is the easiest one to find. Because there's a 90-degree angle already specified, that means B is the complement of 22.3. And 90 degrees minus 22.3 is equal to 67.7 degrees. Now, in order to find A relative to 22.3 degrees, that's the opposite. To find B, that's the adjacent. And then this says that A is 10 sine 22.3 degrees, and B is 10 cosine of 22.3 degrees. So you pull out a calculator and calculate these, and we'll get A is approximately 3.79, and B is approximately 9.25 when rounded. In the next one, now B is 37.4. Little b is 6. And we can find A right off the bat by doing 90 minus 37.4. (52.6 degrees for A. All right, so now we want to find C and we want to find little a. Relative to B, I got the opposite of 6 and I want to find the adjacent. So that's going to be tangent 37.4 equals opposite over the adjacent. Multiply both sides by A, and A is 6 over tangent 37.4. That gives us 7.85. Around 7.85. And then C, that's the hypotenuse relative to B. And so we would use the sine, because 6 is opposite over C, and multiplying both sides by C says that C is 6 divided by the sine of 37.4. Pull out a calculator on that one, and we get 9.88. So we have A being 7.85 and C being 9.88. if A is 2 and C is 7, now we don't know what A or B are, so let's go out and find A first. And that 2 is opposite the A, so that's sine of A is the opposite over hypotenuse. And so we have to use inverse trig functions for this. Inverse sine of 2/7, and lengths are rounded to 2, and the angles are nearest 10th, so that's 1 decimal place. So this gave me 16.6 degrees. Now once we know A, B can be found by just taking the complement, which gives 73.4 degrees. Now you could certainly use the trig functions to find the third side, B, but I'd rather not do that because those are all rounded values. So let's go ahead and use Pythagorean theorem that says b squared plus 2 squared equals 7 squared, or b squared is 49 minus 4, or 45. B is the square root of 45, which when rounded to 2 decimal places comes out to about 6.71. And then if A is 1.4 and B is 3.6, this time relative to A, we've got opposite over adjacent. So the tangent of A is 1.4 over 3.6, making A equal to the inverse tangent of 1.4 over 3.6. So you must use a calculator to estimate that. And that's around 21.3 degrees. B is the complement of 21.3 degrees, which turns out to about 68.7 degrees. Lastly, we have to find C, and this time A squared plus B squared equals C squared. So you have to use a calculator to do this. C squared is equal to 14.92 exactly. So C is equal to the square root of 14.92, which rounded to 2 decimal places is 3.86. And this concludes this video for these problems from section 2.4.